So now if you do this on this, what result do we get? SYY now I can substitute this in that. Into e to the power of j omega n. But premature. How do I get rid of this? How do you get this out of this? If you give me R, I can get S. If I give S, how do I get R? Inverse transform, right? Equivalent to inverse Z transform. And I should write something here similar to my inverse Z transform. So by definition, take it at the moment, this is a relationship between the transform and the inverse transform. Actually, you can even use the take that as the definition 1 by twice by correct. If I now use this definition here, what do I get? This is equal to that is my definition of Sx. So I get my Rxx n plus p. This I must multiply by rho hp and sum over all possible n and p. Are you with me? I can separate this out. xx n plus p. This is okay or not?
There is another term
Which is the term?
from above e power minus k.
Yes. I still have to write that, is it? Good, you helped me. So this and this goes out. Something somewhere I'm going wrong. Very man is gone, is it? Something going wrong here. Let me do carefully. This is equal to I'm getting confused. I think you people have now found my mistake. I am getting confused with omegas. That is where the problem is. This omega is omega 1 and this omega is different. One is a dummy variable and other is the actual variable omega. Because this is to be integrated over omega, so dummy variable. So you will not cancel this. You will get e to the power of j omega and j n into omega minus omega 1. Summation over n. And that will be a delta function. Would you agree or not? Anyway, what it comes out to be, maybe we will follow it up in the next class. It comes out to be equal to Sxx very simple, beautiful result. The output spectral density is equal to input spectral density multiplied by modular square of the transfer function of the black box. This is a very fundamental result. This is on the assumption that the input process is Whiteson stationary, and knowing the spectral density of this, I can find out what is the spectral density. So the third result we got now today is Syy omega is equal to in next class I'll clean this up to prove that this is equal to this, but that is the result. And we'll take this result in the next class and try to find out some important properties of this, the process of transmission of random processes.